Okay, let's have a look at Theta exercise 103, question 6c. Again, this is another gradient question, and we're going to use the formula gradient is equal to y2 minus y1 over x2 minus x1. So the question is p, comma q and q, comma p. There are the coordinates, and let's have a look and find out what the gradient is. So we've got p, comma q, and q, comma p. So again, I'm going to designate these as x and y. So this will be x1 and y1, x2 and y2. Let's get my x's actually joining up. All right. So here it is. I'll state it again. M. And it's a good idea to practice the equation because you're going to be using it a whole bunch. Okay, in any coordinate geometry sort of situation here. All right. So what's my y2? It's going to be p. This equals p minus y1 is q over. Now I've got an x2, which is a q, minus x1, which is a p. Fantastic. So I've got p minus q over q minus p. All right, well, this is a classic situation where these are pretty much the same if I was just to factorize something. So why don't I factorize either the top or the bottom, doesn't matter which. But I'm going to factorize the top, and I'm going to pull out a -1. And by pulling out a -1, it makes them both seemingly the same. So I'm going to go -1 times, now, what times -1 makes negative q? Well, q does. -1 times q is negative q. And what times -1 makes positive p? Well, negative p would be -1 times negative p is positive p. And this is all over, and we're just going to leave this as q minus p. So straight away, if I put that in brackets, you can see that these two are exactly the same. So of course, anything divided by itself is 1. I'll put a 1 there. Equals -1 over 1. Well, -1 over 1 is just -1. And that is my solution.